All right, my friends, problem 5 says, which of the following statements about the function given by f of x equaling x to the fourth minus 2x cubed is true? And then the options have information about extreme values and points of inflection. So for extreme values, I'm thinking first derivative, maybe some second derivative work, and then for points of inflection, I'll be using the second derivative. So, so getting started here, we'd have f of x is given as x to the fourth minus 2x cubed. F prime of x would be 4x cubed minus 6x squared. Sooner or later, we're going to be setting that derivative equal to 0. I think I'll go ahead and do that now. I'm going to factor the right side. And then solving for your critical numbers. Okay. Now, as far as determining whether these critical numbers actually result in a maximum or a minimum value, or if they're kind of a fool's gold type critical number where you get an inflection point instead, you could either do interval testing and do first derivative test work where you look for when the first derivative is positive and negative, and then you can make conclusions. But for this problem, since they asked me about inflection points, I'm going to have to do the second derivative sooner or later anyway, so you're going to see me not use first derivative test. I'll use second derivative test instead. So f double prime would be 12x squared minus 12x. And then sooner or later, we're going to set this equal to 0 to find critical numbers. So I think I'll go ahead and do that now. Or not critical numbers, but inflection points. So I'm going to factor the right side. Okay, so now for tying these two things together. If you want to know whether these critical numbers result in maximums, minimums, or neither, then you can just plug them in to the second derivative. So for example, f double prime of 0 is 0. So that means that you have an inflection point there. So you don't have a maximum or a minimum. And then f double prime of 3/2. A comment there, you can go back to the original version or you could use your factored form. For this purpose, I really like the factored form. Because I really just care if I have a positive or a negative number, and I can tell I've got a positive times a positive, and 1.5 minus 1 is positive. So I can tell that I'm dealing with a positive second derivative here. So if my second derivative is positive, that means my graph is concave up. And then if the first derivative is 0, which it was, that's how we got it in the first place, that means you're not just anywhere on the concave up graph, but you are at the bottom. So what do we now know? At 0, we have an inflection point. At 3/2, we have a minimum value. And then at 1, since f double prime of 1 is 0, we would have an inflection point. Okay, now just a comment, if either of these were in my list here of multiplicity beyond 1, like if any of them were of even multiplicity, then I'd probably have to be a little more careful here about my assumptions. Maybe I would do interval testing on the second derivative to make sure that your graph changes concavity there. But I did get that I had 2 inflection points and then 1 minimum value, which should match up with 2 points of inflection. Where is it? I would say C. There we go. All right, so let's look. Was that right? Did that match the answers in the back? This was number 5. Yay! We got it right. All right. Hope that makes sense. Feel free to contact me if that explanation still doesn't make sense. Hope you're doing great.